Swayam Prabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on another joining process, that is called brazing joining process. So, last lecture I was discussing about soldering process. So, last lecture we have seen that depending upon the phases, the welding can be categorized into three groups. What were that three groups? I was discussing that three groups were first one is called solid state welding process, another one is called liquid state, another one is called solid liquid state. So, last lecture I was discussing a process which lies in both solid and liquid phase joining process categories, that was soldering process. Now, another welding process today which I am going to deliver, that is called brazing process, that also lies in same category, that means it is also lies in solid liquid phase categories. Now, I will discuss in details about brazing process. First of all, I will discuss today's content, that is introduction, difference between brazing and welding, then principle of operation of this brazing process, then step of brazing procedure, then 4 very important requirement of a brazing process, then what are the different types of filler material and fluxes used in brazing process, then different categories of brazing processes, and finally we will discuss what are the advantages, disadvantages and its application. So, first of all, brazing generally what I have already told you, brazing is classified by American Welding Society as a liquid solid phase bonding or joining process, we can say. The filler material which is generally used here is melted, but whatever the base material in which we are applying this filler material, this base material does not melted here. Okay. So, here one thing you should keep it in mind, if this is done very preciously or correctly, then this bonding strength generally is can be more than 5 times of the strength of this filler material. Whatever the filler material used to join this base material generally or join this adherent, generally this strength can be more than 5 times of filler material. Okay. Now, we will define what is brazing process. So, in brazing generally collisions is produced between the adherent by heating them to a suitable temperature, which is generally above 427 degrees centigrade temperature. So, it is 427 degrees centigrade temperature. So, last class we discussed about soldering process, where what we observe here, there the temperature generally does not go beyond 427 degrees centigrade temperature. So, depending upon this 427 degrees centigrade temperature boundary, we generally categorize these two different joining process. One is called solid soldering process, another one is called brazing process. So, generally soldering process lies below 427 degree centigrade temperature range, whereas brazing process generally here the temperature range above 427 degree centigrade temperature. And here generally it is done by using a filler material which has a liquidus temperature above 427 degree centigrade temperature and below the solidus temperature of base material. Generally these things you should keep it in mind. So, whatever the filler material here we are going to use, this filler material should have a very important characteristics. That means its this filler material temperature should above 427 degree centigrade temperature, but in case of soldering process or brazing process, generally this base material should not melt. That is why the filler material temperature should below the solidus temperature of what it is called base material. Now, we will discuss what is the difference between brazing and welding. So, we observe that the difference between soldering and brazing, the main difference is the temperature difference. Generally in case of brazing process, what we observe, the temperature is above 427 degree centigrade temperature, whereas in soldering process generally temperature is below 427 degree centigrade temperature, and rest of the thing is more or less similar, you can say. So, but in case of brazing and welding there are difference are there, like what happens generally in case of brazing, you can see first point I have written, in case of brazing surface to be brazed are not raised to fusion point. So, whatever the base material here we are using, that should not go beyond its melting point. Fusion temperature means above melting point temperature. Okay. So, here surface does not goes beyond its melting point temperature in case of brazing, but in case of welding, whatever the two surfaces we are going to join, that temperature generally goes above its melting point temperature. That means here actually the base material is melted. Here this I have written here. Okay. Now, in second difference is in case of brazing, due to capillary action the molten brazing flour alloy is spread along the joint. Okay. Here one thing you should keep it in mind, what is capillary action? Now, capillary action is the ability of a liquid to flow in narrow space without the assistance of, or we can say even in opposition to, external force like gravity. So, it occurs because of intermolecular forces between liquid and surrounding solid surface. That is very well known to you, that is why I am not going in details about this capillary action in further details. Now, in case of brazing, generally due to capillary action the molten brazing filler wire generally spread along the joint. So, it is spread along the joint, these things you should keep it, it is generally spread along the joint due to this capillary action, this molten filler wire. Whereas, in case of welding you have seen molten filler material in the welding, it solidifies almost at the same place where it melts. These things you should keep it. But in case of brazing, the filler wire generally is spread and it's go to required position by capillary action. What I am telling, understand? But in case of welding, wherever the material is melted, in that location itself it solidifies. What I am telling, understand? There is generally another most important difference between brazing and soldering is there is no penetration in case of brazing process. Penetration means there is no penetration into the base material in brazing joint. What I am telling, understand? That means whatever the filler material we are using, that generally lies above the surface only. It generally does not penetrate into the base material, there is no penetration. But in case of welding, joint generally achieved due to penetration into the base material. That means whatever the molten material is generated in case of welding, that molten material generally you can see penetrate within the base material. That I have shown here in this figure, you can see below this slide I am showing this figure. Here you see this red color zone generally represent the what it is called, red color zone represent the weld zone, you can say. For joining T section, both the piece generally here you can say some partial melting taken place and penetration of this molten material taken place on both the pieces to be joined. Okay. But in case of brazing, you see this red portion represent the filler wire zone, it does not generally penetrate inside this plate or this plate zone. Okay. These things you should keep it in mind. Now, what are the principle of this brazing operation? Here most three steps involved in case of principle of brazing operation. The first one is the molten filler material related thing, second one is called capillary flow, and third one is a very important parameter, that is called high fluidity of molten filler material. So, first of all, in case of principle, the first point is the molten filler material should have the following property, like what happens, the molten filler material should wet the base material surface, whatever the base material here we are using, that base material should be wetted by molten filler wire. That means whatever the wire we are using as a filler wire, that filler wire on its melt, that should wet the surface of the base material. Okay. Now, second one is called spread along the joint by capillary action. This filler material should spread along the joint by which action? Capillary action, which I have already told you. And third point is this it should adhere and solidifies to form braze joint. So, this flare material should have the following properties, okay, for the principle of what it is called brazing process. Now, second one is called capillary action. This capillary action, or you can say capillary flow, plays a major role in case of brazing process. Generally, it provides the base metal surface are wet by molten flare material. So, due to this capillary flow, generally the base metal surface are wet, or you can say are wetted by molten flare material. Okay. And another most important part of this brazing process is the high fluidity of molten flare material is very much essential. So, whatever the molten flare material here we are going to use, that molten flare material should have very high fluidity. Another important thing before going to discuss in details about principle of operation, here you should note that flux which generally used in case of brazing process, its melting temperature generally lower than what it is called flare wire. Flux, what is flux? That is very well known to you. In last class already I have discussed. For soldering purpose there is also used some flux. Flux generally used to prevent oxidation, or it is also used to generally clean the surface to be joined, that purpose, and also it's also act as a property to improve the fluidity or wetting ability of the surface. That already I have discussed in soldering, but there was used different types of flux composition, but here in case of brazing also there will be used some flux, but that composition will be different. What are those composition, that things I will discuss in details here. So, but here one thing you should keep it in mind, this flux which are going to use here, this temperature generally lower than the brazing flare wire. So, whatever the flare wire are using, its flux temperature generally less than of that one. Okay. Now, so the molten flux wet the surface to be brazed, remove the oxide film and gives clean surface. Why it is required? It is less temperature than flare wire, because it helps to molten the flux, wet the surface to be brazed, and it also remove the oxide film and gives clean surfaces. These things you just keep it in mind. Now, I will continue this principle of this brazing process. Generally, the joint is produced here by a process, that process is called diffusion of element of flare material into the base material or vice versa. This is the main principle you can say of brazing process. Here generally whatever the joining is done here, that joining generally done by diffusion process, that you can say. Now, what is diffusion process? That is very well known to you. Generally it is the movement of a substance from an area of high concentration to a region of lower concentration, like this types of concept you are very well known to you. I am not going in details about diffusion process. So, diffusion generally is driven by a gradient in concentration. That is why generally here diffusion is done, like here liquid and solid types of diffusion process is going on, liquid flare wire and solid base wire. So, that is why here due to this diffusion this bonding is created and joining is done. So, this third point I have already discussed, the capillary action is play an important role in holding the liquid flare wire. Here one thing you should keep it in mind, whatever the flare wire we are going to use, this flare wire should have good wettability. To have good wettability in flare wire, and here one thing you should keep it in mind, its wetting angle should less than 90 degree. Now, we should know what is wetting angle. Generally wetting angle you can say, just I am just discussing, wetting angle is the angle between the contact surface, let this is the droplet, between the contact surface and tangent at the corner point. This way we can define. This is droplet, this is the droplet, or you can say drop of molten flare wire. Let this is solid base material, solid base. Now, if you draw a tangent here, this tangent makes a angle with horizontal surface of this solid base material. That angle is generally called, what it is called, wetting angle. Here one thing you should keep it in mind, for good wettability of a flare wire, this contact angle should less than 90 degree. So, lesser the contact angle, better the wettability of filler wire. These things you should keep it in mind, because generally good wettability is required for filler wire. That is why I have written in this point here, you can say the presence of another important point you should keep it in mind, the presence of adsorbed molecules on a metal surface significantly decrease this surface energy of solid vapor interface, and thus increasing this contact angle. So, you see this as generally this adsorbed molecules. What is this adsorbed molecule? That also you should know. Adsorbed molecule means it is oxide, grease, or that means some sort of substance which generally developed due to non-cleanliness of the surface, or you can say uncleanliness of the surface. That can be due to oxide, or due to the grease, or due to some other substances. So, these types of adsorbed molecule generally acts as a degradation of this wettability, or you can see it generally increase the this wetting angle, it generally increase the wetting angle. That is why you should keep it in mind when you go for joining any surface by brazing process, that surface should be clean enough. That means there should not be any adsorbed molecules. Adsorbed molecule means like oxide or grease, or this third particle, you can say, that should not be there. Okay. That is why here I have written in this point. So, during brazing, surface should be free from any oxide layer or impurity. That means this impurity means that can be residue of what is called flux, that is called slag, or that can be residue of oxide. So, these are impurity should not be there. So, generally you should keep it in mind, good wettability is the main requirement of filler wire for brazing purpose. Okay. So, good wetting generally increase the brazing efficiency. These things also you should keep it in mind. Now, here I am going to discuss about the steps which generally follow to do the brazing procedure. These are the following steps I am showing. First of all, the first step is to clean and preparing the surface for brazing. These things you should keep in. First of all, we should clean the surface properly, because I have already told you why cleaning is required, because to get a good wettability of this filler wire which we are going to use to join the base material, that filler wire should have good wettability. Then only what happens, your capillary action and joining quality become proper. That is why cleaning of any what it is called impurity or oxide is first step for doing brazing operation. Okay. Because if there will be any impurity, then this wettability or wetting angle increases. So, once wetting angle increases, this wettability decreases. What I am telling, understand? So, second point is fluxing both base and filler material surface. So, first clean, then we have to apply the flux over the surface as well as over the base material surfaces. And third point is align the base material part to be joined. So, after that we have to position the base materials which we are going to join. That things we have to align as per our required configuration. Alignment means as per our required configuration we have to align the base material. Okay. Or you can say we have to align the part to be joined. After alignment, third step is heating the joint. So, you see everything is coming sequentially. So, then we have to do the heating of that joining portion. Okay. After that we have to apply brazing filler material on the joint. Then once brazing filler material in molten state we apply in this joining region, after that we have to solidify. That means we have to cool that brazing joint. So, once this brazing joint cool and joining is made, after that what are the last step? We have to remove that flux residue from the completed joint. If there is any flux residue, then that can be promote corrosion. That is why what happens, we should remove that flux residue. Okay. So, these are the around 8 different steps we should follow during brazing operation. Now, here in next slide I am just showing here one thing you should keep it in mind. These are the most important 4 different requirement of brazing operation. What are those 4 different requirement? you can say. First one is called clean the metals or clean the base material to be joined. Then we have to use appropriate filler material. What are those filler material? I will explain here in details. And we have to use correct flux. So, what are the flux we should use for what types of material, that also I will discuss here. And heating, this is also another important parameter, that means what types of heating is required for joining purpose. So, first one is clean the metals to be joined. So, first of all here you see, we know generally molecular bonding require a clean surface, correct. Whenever there is a molecular types of diffusion and other things occur to join two substance, that surface to be clean enough. That what I have already discussed in earlier slide also. There should not be any impurity, there should not be any oxide layer, what I have discussed. So, this clean does not means it should be polished surface. Clean does not mean it is a polished surface. Always keep it in mind, clean means generally for doing brazing process, it should not be polished on. It is better to use grind types of surfaces. That means what happens, best method for cleaning the surface is grinding method. Okay. Now, second requirement is appropriate filler wire. This is the second requirement in case of brazing process. Say whatever the brazing alloy that, or you can say filler wire we use for joining the base material, that braze alloy generally available as rod, ribbon, powder, paste, cream, wire, or you can say some preform types of form is also there, that preform types of brazed alloy also use, like this preform types of brazed alloy like stamped washers, one of the types of this preform types of brazed alloy, which are generally used as a filler wire in case of brazing process. And another things you should keep it in mind, this brazing rod or wire which are generally we are using in case of brazing process, this can be available as bare rod or flux cooled. What does it means? So, I have already told you, generally in case of brazing process, this is one plate, over there I am going to join another plate. Okay. So, for that reason, first of all this surface and this surface we have to clean properly. This cleaning generally is better to do by using grinding operation instead of polishing. Okay. After that, what are the things required to do? We have to apply the fluxes where we are going to apply the filler wire, that you can say. So, after that we have to apply this filler wire means, or this filler wire can be rod, ribbon, powder or filler powder. So, this filler wire generally this is a filler wire, you can say this is a filler wire, filler. This filler generally melted due to heating, this filler melted due to heating and it deposited in this region. So, once it deposited then due to this fluidity and its capillary action, it is going to its required location where generally joining, that means its flow in the joint location due to capillary action, and after that it solidified and do the joining. So, you understand. So, that things it is already what I have already explained clearly. Now, this filler material which we are using can be pre-placed at the desired location or applied during heating cycle. So, you see this filler which we are using, that can be pre-placed, that means before heating itself we can pre-place over there as a powder form or as a ribbon form or as a paste form, cream form in this region. After that we can apply also, or we can use this thing during brazing cycle itself, during heating cycle itself. That means at the time of heating, some sort of heat source we are using here. By this heat source generally we can, this is a flame types of heating, we are heating both these surfaces as well as that filler wire. At that time also we can place this filler wire during heating cycle, that is called during heating cycle. The heating cycle means at that cycle we generally used to heat both this base material as well as filler material. What I am telling, understand? Now, this filler material and its application, that things also we should know. So, you see this filler material for manual brazing is preferable as wire or rod types of form. This wire or rod types of form which are generally very easy to use in required location. What I am telling you, that is why generally in manual brazing wire and rod forms are generally used. In the case of furnace types of brazing, here you see in second point I have written, say here generally alloy is usually placed beforehand. So, in case of manual brazing, there wire or rod form which are used, it is generally used during the heating cycle itself. What I am telling, understand? During the heating cycle itself means once we heat this base material as well as fly material together, at that time generally this rod or wire generally used in manual brazing operation. But in case of furnace types of brazing, beforehand we usually placed the flare wire, or you can say we usually place the filler material. These things you just keep it in mind, because in furnace types of brazing operation this filler wire use in first, after that generally it passing through the furnace. What I am telling, understand? And during passing through the furnace, the pre-placed filler wire is melted, and this molted filler wire generally goes in required location by capillary action, and after that joining is done. Okay. Now, this filler material which are commonly used, I have classified here, you can say I have shown here, like it can be aluminum silicon types of alloy, which is a very general purpose types of filler wire. It can be, this filler wire can be magnesium filler wire. It is generally used for brazing of magnesium alloy. Then this filler wire can be copper or copper zinc types of filler material. It is generally used for joining, you see this is a copper or copper zinc type filler wire, have wide application. You can see it can be used for joining ferrous alloy, nickel based alloy, copper and nickel based dissimilar alloy also. These types of copper and copper zinc types of filler wire are generally used. Then another is called gold filler material. It is generally used for joining parts which is used in electron tubes assembly. Okay. In electron tube assembly, generally one very important thing you should keep it in mind, where volatile components generally are undesirable. So, that is why in case of electron tube assembly, gold types of filler wire are generally commonly used. Okay. So, another one is called nickel based filler wire. It is used in stainless steel, nickel and cobalt based alloy. Another one is called silver filler wire. It is also used for joining ferrous as well as non-ferrous material. So, silver can be used ferrous as well as non-ferrous, but you should keep it in mind, silver is not good for aluminum and magnesium. That is why here I have written that non-ferrous metal except aluminum and magnesium. These things you should keep it in mind. Generally for joining magnesium by brazing process, magnesium alloy is separately used. Okay. Now, you see we will discuss about what are the flux and what are its function, then what are the different composition of fluxes, that things also I will discuss here. Here one thing you should keep it in mind, unless brazing operation are continued within a inert medium or a vacuum chamber, that means if brazing operation is done in a inert medium or in a vacuum chamber, there generally flux is not required, except that inert medium and what is called vacuum furnace, a flux generally commonly used as borax, which is generally required to prevent oxidation. What I have already told you, the main purpose of flux is to prevent the oxidation of filler as well as base material. Why this flux is required? First one is it generally prevent the oxidation, it also increase the consistency, also you can say, and it help to produce consistently sound braze joint. Now, what are the function of this flux? First function of this flux is, its main function you can say, its main function of this flux is dissolve the oxide and remove it from the surface. These things you should keep it in mind. Okay. So, it generally dissolve the oxide and remove it to the surface of molten filler material. It is also spread ahead of the filler metal and protect the metal surface from oxidation. So, this flux generally is spread ahead of the filler material. So, once it is spread ahead of the filler material, during this moving of this flux ahead of the filler material, it is beforehand clean that surface. After that generally its filler material pass through that region. Okay. That is why it is also protect the metal surface from oxidation. It also serves the purpose of cleaning any contamination left on the brazing surface. It's help to promote the capillarity of filler material. This is a very important point, that flax have a function which also increase the ability to wet, as well as it also promote the capillary action. But here another things you should keep it in mind, excess flax should not be good, because excess flax should be removed when the cycle is completed, because flax left in the joint can lead to corrosion, because flat can have some corrosive property. So, that is why what happens, if excessive flax you use, then this residue of that flax can do the corrosion types of effect. Now, what are the constituents of flax? Flax can be applied in flax paste, liquid, powder, or pre-made brazing paste that generally combine flax with filler material. Pre-made brazing paste, what does it mean? It is a paste which contain both filler wire and flax together. What I am telling, understand? So, at a time we can use this filler wire flax combination paste and we can serve our purpose. So, it can also be, this flax can be coat over the surface of the filler wire, or it can be the core of this filler wire rod. What I am telling, understand? That means, this is a filler wire which we are going to use for join the base material. So, what we can do? We can use this flax over the surface, that means a layer of paint types of things we can provide over the surface of this filler wire, or we can make a hollow types of cylindrical filler wire. So, that means a hollow core we can make. Inside this hollow core we can use the flax. What I am telling you, this is called core flax, or you can say flax core. This types of way also we can use flax in case of filler wire. The constituent of flax are fused borax, it can be fused borax. This is a commonly used flaxes which are generally used for high temperature flaxes. Okay. Then there can be constituents such as sodium, potassium, lithium, borate types of compound. These types of compound also used for high temperature. High temperature means where the temperature is 760 degree centigrade and it is above, there generally these types of compounds are used. This flax constituent can be fluoroborate. It is generally is a compound of fluorine, bromine, active metal, that is potassium or sodium, and this composition can be chlorides. This composition can be boric acid, and this boric acid generally act as a cleaning agent. Okay. And this constituent of flax is sodium and potassium hydroxide and water. These are the following constituents of flax. Now, how to remove this flax? That also you should know. Generally, for removing this flax, we can washing the braze part in hot water. We can rapid immersion of this warm braze part into cold water. We can remove this flax by using some chemical solution, that means dipping the part in chemical, and this flax also can remove by some mechanical means such as wire brushing, chipping, shot blasting, steam jet cleaning. So, the different types of mechanical process are there by which we can remove this flax. Okay. Generally, here another things you should keep it in your mind, that brazing atmosphere can be either vacuum atmosphere or it should be controlled atmosphere. Controlled atmosphere means some inert atmosphere where generally chances of oxidation should be less. That means there the controlled atmosphere means it should protect the what it is called oxidation. Now, this heat. During brazing process we know that heating is the most important part. That is why different types of heat source generally used in case of brazing operation. Like some of the heating process here I am just showing, like this heating process can be non-fusion types of heat source, which are generally some different types of gas reaction types of heating process, like it can be oxyacetylene types of heat source, it can be air acetylene types of heat source, it can be air propane, oxypropane, or it can be MAPP types of heat source. MAPP full form is methyl acetylene propadiene. So, that means it means MAPP means methyl acetylene propadiene. Okay. It can be electric soldering iron, it can be electric soldering gun. Now, I will discuss about different types of brazing process. So, depending upon the heat source you can say or heating of the component, the brazing can be categorized into different types of categories, like it can be torch brazing. Here I am showing around 13-14 different types of categories of brazing process. It can be torch brazing, it can be furnace brazing, it can be vacuum brazing, deep brazing, salt bath brazing, infrared brazing, electric blanket brazing, induction types of brazing, resistance brazing, exothermal brazing, carbon arc brazing, flow brazing and block brazing. So, these are the commonly used brazing process based on method of heating actually. Now, little bit details I will discuss about this brazing process, like in torch brazing it is a localized heating techniques. In this method generally the heat required to melt and flow the flare material which is supplied by fuel gas flame. So, here generally fuel gas flame is used to heat the base material as well as flare material. Okay. This fuel gas can be what I have already explained in earlier slides, can be fuel gas can be acetylene, hydrogen or propane. It generally combined with atmosphere, it develop the flame and which is used to heat the brazing part. Okay. Now, this process is readily automated and it require very low capital investment. These things you should keep it in mind. So, this torch brazing is a very low cost types of brazing process. This torch brazing can be manual, it can be machine operated or it can be automatic types of torch brazing process. Induction brazing, here the heat is generated by induction principle. So, here generally high frequency induction heating is done for brazing purpose, and this brazing process is generally very clean and rapid process, and it is generally giving close control of temperature and location of heat. Here another things you should keep it in mind, whatever the heat is created, that heat is created by a generally rapidly alternating current. This alternating current which is generally inducted into the workpiece by an adjacent coil. So, whatever the heat is created, that heat is created by some rapidly alternating current. This heat is generally inducted into the workpiece by some adjacent coil. Then that means another adjacent coil is used, that coil generally used to transfer the heat in required location. Then resistance brazing, in case of resistance brazing, generally whatever the part we are going to braze, that part is makes as a component of that electric circuit. What does it means? That means here generally electrical resistance is used. So, this electrical circuit set in such a way, the part which we are going to braze, that part act as a circuit component. So, once the current flow this circuit component, then in that location due to resistance heating, heat is generated, and what happens, it melt the flare wire and it also do the what is called brazing operation. So, this process, this resistance process is most applicable to relatively simple types of joint in metal which have highly electrical conductivity. Okay. Now, diffusion types of heating techniques, it can be furnace brazing, like this furnace brazing is a very popular brazing techniques you can say. It is generally used in industrial brazing operation because it has a very high adaptability to mass production, and here a less skill labor is required. It offers two prime advantages. Generally this furnace brazing offer two main advantages, like this furnace brazing is done in a protective atmosphere condition where generally high purity gases or vacuum which negate the need for flux. So, here generally we can eliminate flux, or we can say we can avoid the use of flux. Here generally heating is either through some element or by gas firing. In furnace we can use some heating element to heat the braze part, or we can use separately some gas firing to heat the braze part in required location, that is in furnace. Okay. There are generally four main types of furnace which are commonly used for brazing operation. One is called Bayes type of furnace, continuous furnace, retort with control atmosphere furnace, and vacuum furnace. So, these are the four different types of furnace generally we use for brazing purpose. I am not going in details about these things. Here just schematically I am showing how the furnace brazing is done. Let us this part and this part we are going to join to make a T joint. So, first of all we use this filler wire here, this circle we are representing as a filler wire. So, after that this assembly we done outside of this furnace, after that we put this filler wire combined with these two pieces in furnace. So, in furnace generally heating is done and this filler wire melting is done. After that, due to capillary action, this filler wire is spread in this joint section, and once this filler wire is melted, it is generally removed from this furnace part. You see continuous arrow I am just showing, and outside generally this is the braze joint. It cool down and it makes the joint like this. Okay. Now, that another categories of this brazing process is called deep brazing. You see this deep brazing it involves generally immersion of the entire assembly into bath of molten braze alloy, or you can say molten flux. So, whatever the molten braze alloy bath is there, that is containing either molten flux only, or it can be containing of molten braze alloy and molten flux combination. So, in both the cases this bath temperature is below the solidification point of base material, or you can say parent material, but this molten bath temperature should be above the filler material temperature. So, this deep brazing is especially suited for brazing aluminum, because aluminum is reactive types of material, you can say. Generally what happens, so aluminum is such a material, if we use this thing, if we just keep in open atmosphere, it collide with atmospheric oxygen and a oxide layer is formed over the surface of this aluminum, that is very well known to you. So, that is why what happens, to prevent this oxidation, generally aluminum brazing is preferable in deep types of brazing process, because if we dip this aluminum part inside some molten bath, then what happens, this atmospheric contamination with aluminum will not be there. So, that types of oxidation formation chances will be less, because this oxide is a refractory types of material. What I am telling, understand? Like Fe Al2O3 or Al2 aluminum oxide actually is a very high melting point types of oxide. Okay. Generally aluminum, if it has a melting point temperature 600, whereas this aluminum oxide have a melting point temperature is around 1400 degrees centigrade. What I am telling, understand? So, this generally once it is include in that joining region, it act as a inclusion, that is a defect. That is why to do aluminum types of welding, it is better to use deep brazing, because if we will this molten bath deep, and if we just keep this assembly inside this molten bath region, then chances of that types of oxidation will not be there. That is why here I have written, for doing aluminum brazing, deep brazing is preferable. Now, the part to be joined are first fixed and the brazing compound applied to the mating surface. Typically this brazing compound is in slurry form. These things you should keep it in mind. Slurry form is it is a paste types of form, combination of liquid solid. Then the assembly are dipped into bath of molten salt. This whatever the molten bath we use, this is actually the bath of molten salt. This molten salt generally sodium chloride, potassium chloride or some other compound, which function as both heat transfer medium as well as flux. Okay. Many deep braze part we have seen in heat transfer application for aerospace industry. Now, infrared types of brazing process. In infrared types of brazing process, here generally infrared types of brazing heat is a radiant heat which is obtained below the red ray in the spectrum. This heat source in infrared brazing is a ring of high power lamp. So, whatever the heat source we use, this is a ring of high power lamp which enables the energies to impinge on the part. It is a suitable process for hidden and inaccessible types of joint area. And another categories of this brazing process is called block brazing. This block generally brazing process, here blocks heated with a gas flame or electricity. After that, this block applied at the joint in base material which is to be brazing joint. Okay. And last category is called flow brazing. Here generally the molten filler material is directly poured into the joint between the part to be joined. So, here first this filler material converted to molten state, after that this molten filler material are directly poured into the required location for brazing purpose. That is why it is called flow brazing process. Okay. Now, this brazing joint should have the following property. That means this first property is the filler material can be placed on one side of the joint and it should pull through the joint by capillary action. So, whatever the joint we should design for brazing purpose, first of one we should keep it in mind, we are generally use the filler wire in one side, and after this generally this filler wire should go through the entire joining region through capillary action. That types of joint we have to design, and it should have the following property. That means it should have a good mechanical performance, it should have good pressure tightness, it should have good corrosion resistance, and it should have good appearance. So, these are the following property of the joint property we should keep it in mind. Based on these things we should design our brazing joint. Here another things you should keep it in mind, generally brazing alloy is subjected to shear types of force. That is why, because brazing joint most of the cases it is observed it is subjected to some shear types of loading condition rather than direct stress condition. That is why it is better to use brazing joint in lap joint form. What I am telling, understand? In lap joint is preferable for brazing joint. And another important point for brazing joint design is setting up the correct gap. That means clearance is an important factor in joint quality, because if this gap will not be correct enough, then capillary action and other things will not be occur correctly. What I am telling, understand? That is why setting up the correct gap is very much important. Just here I am showing some of the type of brazing joint. It can be butt form, it can be lap form, it can be scrap bar joint, what it is called as inclined joint between two pieces is called scrap bar joint. It can be T joint, here two pieces of base material placed perpendicular to each other makes a T form, that is why it is called T joint. It can be flange bottom, these types of joint also we can use in case of brazing purpose. Now, we will discuss about advantage of this brazing process. Like generally brazing process can be used both similar and dissimilar types of metal. In general, brazing produces a less thermal distortion than welding due to the uniform heating of the braze piece. This is a very important part. Okay. That means, in case of brazing joint we generally get less thermal distortion than welding joint assemblies. Okay. That means, brazing produces less thermal distortion than welding, because in brazing the uniform heating of the braze part is occur. Okay. It can fabricate large assembly in almost stress free condition. Okay. This is another very important advantage of brazing process. The brazing can be coated or clad for protective purpose. That means, this brazing we can use for coating purpose as well as for cladding purpose. Coating and cladding that is very well known to, I am not going in details here. Generally it is used to protect the parent material from outside contamination. That means, we generally use a small layer over some substrate material to protect that substrate material from atmospheric corrosion or oxidation types of purpose. It is also easily adapted to mass production and it is easy to automate brazing process. It is reproducible and reliable quality control technique. As the base material does not melt here, that is why it allows much tighter control over tolerances and it produces a clean joint without the need for secondary finishing. So, in case of brazing joint generally secondary finishing is not required, like in welding some secondary finishing or other thing can be required, but in case of brazing this types of secondary finishing is not required. This is the disadvantage of brazing process, like here generally lack of joint strength as compared to welded joint due to the softer filler material used. The strength of the braze joint is likely to be less than that of base material, but greater than filler material. So, here whatever the joint we are making, its strength is lesser than base material, what I am telling, but its strength is higher than filler material. Braze joint can be damaged under high service temperature, because if the braze component is used in high service condition, there is a chance of damage of that brazing joint. Okay. These joints require a high degree of base material cleanliness. Why this cleanliness required? What I have already told you. Cleanliness generally improve wettability, it improve the capillary action. That is why this cleanliness is very much essential. These joints generally sometimes discolor the component. That means the joint color is often different from that of base metal, which create an aesthetic disadvantage. That means its component aesthetic look changes, because braze joint color is frequently different than its parent material color. Okay. That is why it is creating an aesthetic disadvantage. It require tightly brazed part to ensure capillary flow of filler material. That is why this involves expensive machining to attain the desired fit. So, very expensive machining is required, or very high quality machining is required for doing brazing operation, because here a better tightening or better you can say joining tolerance should be there, so that better capillary action is occur there. And another thing, flux residue if not removed properly can cause corrosion. That is why we should remove the flux correctly. And another disadvantage of this flux and filler material can evolve toxic and poisonous types of fume. Now, the last point of brazing process is its application. It has the ability to join non-metal to metal, it has the ability to join dissimilar metal. So, non-metal to metal as well as dissimilar metal. It has the ability to join porous types of metal component. It also can join cast metal to wrought metal. It is also can apply to join non-metal to metal. Okay. So, these are the different types of application. A specific application I am showing, some general application here I am showing. So, these are the references which I followed in this lecture. Thank you.